Okay, 6.3, testing for parallelograms. What we're going to do in this lesson is that we are going to recognise that conditions that ensure that the quadrilateral is a parallelogram. Okay, and then a set of points will form a parallelogram in the coordinate plane. And here's the conditions for parallelograms, exactly the same as in 6.2. Okay, opposite sides are congruent, opposite angles are congruent, diagonals, the midpoint must also be congruent, and that not only opposite sides are congruent, they are also parallel. So make sure you read through all the theorems to make sure that you've got all the information that you need. Okay, here's example 1. You've got to determine whether the quadrilateral is a parallelogram and justifying your answer. While going through what they've given you as the answer, don't forget opposite sides are congruent, and don't forget your two adjacent angles must equal 180 degrees, which in this case it does. So therefore, by theorem 612, it is a parallelogram. Okay, be careful of questions, a bit like question number 1. It's asking whether it's a parallelogram. Well, if you look at the diagram, it actually looks like a rhombus. But all you're interested in is the fact that opposite angles are congruent. That's one of the properties of a parallelogram. So obviously this guy is a parallelogram. So the answer is yes. Let's have a quick look at question number 2. Is that, well, we know that this is 5 and this is 5, so the midpoint of that line, if we label it A, B, C and D, so B and D are have got the same midpoint, but look at A and C, we've got 5.1 and we've got 4.9. These two guys are not the same, so the answer to question number 2 is purely and simply no. Okay, here's again real life situation. This is a tackle box, one of these concertina type tackle boxes, and it's asking you why that they will remain parallel. Well, but all P, Q, R and S are pivotal, so therefore every time P and Q moves, R and S will go at the same position. So you know, as it says down here, no matter the vertical position of the trays, they will always remain parallel. Okay, sometimes you get questions like this. I'm not particularly happy with them, but you know me and making assumptions in mathematics. Sometimes you can, sometimes you can't. But you know, Charmaine here is building a kite as shown. If we look at the top side of it, you've got no measurements. There is no measurements in the statement. You've got no angles in the statement either. So can you assume that P is the midpoint of AC and BD? Well, in this case, you can. Okay, so you can make the assumption that AP is equal to CP and that DBP is equal to DP. So by that assumption, the answer is quite categorically yes. Okay, and now we're back to algebra. Again, you've got the given statement, so make sure you use the given statements. Well, FK is 3x minus 1 and KH is 2x plus 3. If it's a parallelogram, as you can see, these two guys will equal each other. Again, solve for x. You know me on this, what I would do, plug it back in again. If you get the same value, then the answer is yes. Well, 3 times 4 is 12, take away 1 is 11, so FK would be 11. 2 times 4 is 8, plus 3 is 11, so KH must be also 11. So there, that gives you your check of your algebra. Then, obviously, check for your y's. The other one, you've got 4y plus 3 and 6y minus 2. Again, they must equal each other, which is what they've got here. Okay, solve for y, which is what they've done. And again, plug it back in again. If it plugs back in again and both of them are the same, then we're okay to go. Okay, question number 4. Let's have a look at what you've got. What are the quadrilaterals? Find the x and y. You know now that opposite angles equal each other. So you can do 8x minus 8 equals 6x plus 14. Subtract 6x from both sides. So 2x minus 8 equals 14. Add 8 to both sides. So 2x equals 22. So x would equal 11, and again plug it in. So if we plug it into the 8x minus 8, 8 times 11 is 88, minus the 8 will give you 80 degrees for this angle here. And 6 times 11 is 66, and 66 add 14. That will also, this angle here will also give you 80 degrees. Both of them are the same. You're good to go on the x's. Is it a quadrilateral? You've got to do the y's as well. So you've got 7y plus 2. That must equal 6y plus 16. Subtract 6y from both sides. Y plus 2 equals 16. Subtract the 2 from both sides. Y equals 14. Okay, plug it in. 6 14s. 6 14s is 84. 84, add the 16, that will give you 100 degrees for that angle there. Okay, and it's 7 times 14, that will give you 98. 98 plus 2, this angle would also be 100. So using your x and y's, you can see that opposite angles do equal each other. So question number 4 is you're proving that it is a parallelogram. Okay, the coordinate plane, parallelograms in the coordinate plane. You know me, simple way is to plot the 4 coordinates you are given. I keep saying I'm a visual person. That's the first thing I would do. I know some of you don't have to, but then you work out the slope. Sometimes when you draw it, you've got horizontal and vertical lines. Obviously in this one you haven't, and all you've got to do is the slope. And each opposite sides must be have the same slope in order for them to be a parallelogram. And as you can see, you've got 2 with 1/6 and 2 with 6. So opposite sides are parallel, therefore they are a parallelogram. Okay, so here's the reason why I always like to plot things. If you plot them, and I'm just going to do it very quickly freehand, A would be over here. B, it's got the same y coordinate, so there you've got a straight line over here. C would be down here at -8, 1, so we've got a point here. And then finally D, even though that's got the same over here, it's come to -1, -1. So even though you know these are both parallel because they are horizontal, these 2 guys definitely are not, just looking at the diagram. But if you can't see it perfectly okay from the diagram, then all you have to do is AD and BC if you get different slopes, which in this case it will be, the answer would